All right. Hi, everyone. I'm Ryan. I'm the host for the Applied Economics Skill Series. Just to give you guys ground rules, respectful space, and at 3 o'clock this ends. So if you need to go, I'll give the speaker a bit of time. But other than that, just reach out if you have any questions and stuff. So I'm really excited today to have Haseeb Ali. He's going to be presenting GitHub for academic work. And Haseeb Ali is a PhD student who's a member of the 2016 PhD cohort. Prior to joining the department, Haseeb earned his MS in economics from the University of British Columbia, as well as at Lahore University's Management of Sciences, having started out as a mechanical engineering degree at Worcester Polytech Institute. Haseeb has worked extensively as a research assistant at UMN for about 6 years. And over the past 2 years, Haseeb has worked as a senior data scientist for Secure and Financial. And currently he is on the industry job market as an industry job market candidate. As a data scientist by trade, Haseeb has developed skills in Git, GitHub, and other tools to improve workflow and reproducibility of results. So let's welcome Haseeb.
Thank you, Ryan. It's perfect introduction for kind of what I'm going to be presenting today. Who here actively uses Git, not only for themselves, but in terms of collaborating with other colleagues and researchers? Okay, kind of. Okay. That's kind of what this is geared towards. And I apologize if this, for those who do that, if this is just too simplistic or basic. The point is for kind of those newer users to get an understanding of how Git and GitHub works, specifically in R. That's really the only place I've used it. I am by no means an expert. There might be actually people in this room who are better at using these tools than I am. I was only introduced to real actively using it in terms of collaboration when I joined my job, and that's when I thought, I wish as a student I was introduced to this. So that's kind of my motivation. Again, by no means am I an expert in using Git and GitHub for these purposes. So feel free to correct me if I say something wrong. I will not be offended at all. Okay, perfect. As I said, the goals here are to introduce Git concepts, gain exposure to a common development workflow. It's the workflow I'm going to be sharing is very basic, and what I've heard is they're more complicated ways of using Git and GitHub, specifically geared towards software development and stuff. But for us, right, the point is to use Git and GitHub in kind of that research environment. So because of that, the complexity of the workflow is perhaps not as much as it would be in hardcore software development, think about app development. Those people really have to think about what their workflow is, because if they don't, you can have conflicts and completely crash what you're trying to develop. In our case, it's right, we're working with data, so it's someone is going to most probably be doing the data cleaning, someone is going to be perhaps writing a report, someone is going to be perhaps making visualization, someone's going to be doing the analysis. And obviously all of these things are often done with collaboration. It's not only one person doing it. But that's kind of limits the scope of how we as data science researchers or econometrics researchers are going to be, or applied econ researchers are going to be using Git and GitHub. So before starting, this is not really going to be a hands-on tutorial, me walking you through each one of these things. There are lots of good online resources, and I'll share a couple more towards the end. but yeah, you should have R&R Studio installed and downloaded. You should have a GitHub account. And then kind of takes a while to kind of set that up. But you have to like connect the two. So you have to set up Git and GitHub with RStudio, and there's a resource for knowing it's really nice on how to do that. So what is version control? It's the practice of tracking, managing changes to software code over time. So if you make like a change and then you want to go back to what you originally had, that's pretty much what version control is. But what's kind of more than just version control is the ability to collaborate with multiple people, each working on like a specific part of your project. So because, I'll be working on one part and perhaps someone else is working on some other part, like you want to control all these different versions so that in the end you can harmonize all those changes different collaborators are making. So the most basic thing is a repository. It just means like the project you have. It's a collection of files and folders. And what is nice when working with GitHub, it'll store the history of changes. Specifically, each change is documented by a commit that you have to, run. And so you can kind of track all the changes that you've made over time. As I said, you can think of a repository as a project. Also, people, instead of saying the whole word repository, just say repo, and mostly I'm going to be saying repo as well. So don't get confused when I say repo, I mean repository. The typical repo will contain code files, right, and it will contain a README, other JSON project documentation, whatever it is you want to put in there. Okay, so the like a really important thing to note is the difference between your local and remote repo. There's going to be something which is remote and something which you will be working on your own development environment, on your own computer. So you have your own personal development environment. You're developing kind of your own stuff in that code environment, in that development environment. Once you're kind of satisfied with a change you've made, you will push those changes into the remote environment. And once now you've pushed those changes into the remote environment, a collaborator you're working with can kind of download the changes that you've made, test those out, comment on them, review them, perhaps even take those changes and develop further and like progress after the work that you've done going forward. So yeah, and the remote in our case is going to live in GitHub. So I'm not an expert. There's a difference between like Git and GitHub. Git is like the technique you're using. It's like this organization methodology is kind of how I understand it, which was like developed by a particular computer scientist. And that methodology makes it somewhat easy, but primarily logical to monitor any code changes made between me and you between multiple collaborators. GitHub is kind of the tool which implements that, and the website owned by Microsoft has that space for you to store your code and put it online and share it with other researchers you're working with. Anyone have any questions? Is what I'm saying making sense, or okay? Is this stuff you already know, I'd imagine, or okay? So what is a commit? So I'm going to first talk about what these different actions are within the Git and GitHub environment. And then, kind of depending on time, I'll go over a specific example, which is a very common workflow method that I've used, and I think for 90% of cases that if you're going to be collaborating within that research environment, you will also follow a variation of that workflow. So there are two parts of kind of making a commit. It's not that important, but you've got to stage your changes. So suppose you've made changes to different parts of your repo. You have perhaps a data analysis section, and you have a maybe a table generation section or a data visualization section, right? So you have these different perhaps subfolders within your repo that you're changing. If you've changed more than one of those things, you can stage and say, okay, let's just focus on the changes I've made on the data analysis section. I know I've made changes elsewhere as well, but right now I just want you to focus on those specific changes. That's what staging is called. Once you've specified that, then you make that commit. Then that commit becomes kind of like a snapshot of your repo and the changes that you have implemented, kind of compared to what you started off with. Yep. Mm-hmm.
I have a question about commit sizes. So, do you have any advice on at what points do you do your commits? So,
That's
my
a really good
current
question.
heuristic is kind of frequent and often, so the smallest unit as possible. Or do you try to do bigger, kind of oh, this is a big old chunk of stuff, and that's a whole commit?
Yeah. That's a really good question, and that's why kind of to me, staging honestly kind of doesn't make sense, because if you're making frequent commits, then it's kind of everything you've changed since last time should be in that commit. If you've made lots of changes throughout your repo in multiple places, then it would make sense to first stage and then commit. But as Ryan mentioned, you should most likely commit often, but not with every additional line of code. It's more I want to achieve this goal, actually a sub-goal, because as we'll talk about, the overarching goal is kind of encapsulated in creating a branch. So it's like a sub-goal. I want to perhaps develop a function which will help me achieve some task. After developing that function, you should most likely commit, but not really after every line to create that function. That's kind of how I think about it. But yep.
Just kind of piggyback off that point, different versions of GitHub will have different size restrictions, and there are some circumstances where it will be infeasible to load your data files, for example, up onto GitHub, even the university version. In that case, you might want to just load your do files and your code onto GitHub and then just store the versions of your files on backup hard drives or on your G Drive account, or like, have other backups in place. Because
Yeah, I don't want to really get into this about like what you should and should not be saving on GitHub. But generally, the advice is don't save data on GitHub. Just save your code, which kind of hits the data, works with the data in some capacity. So that's like, even if you have tens of thousands of lines of code, it's generally not going to be more than a few megabytes. Once you start putting your data in there, which you can do, nothing really restricting you from doing it, you'll run into those problems, definitely. Yeah, so okay, move forward. So it's just like, just to give an analogy, if you're like writing a recipe, it's like you have this original recipe, it's great, it does good, and you have kind of like an okay pizza. You want to take it to the next level, so like you start like making changes to that original recipe based off like your infinite wisdom of pizza making and how all this chemistry works, right? And so like you engage in this process by breaking it down into like discrete actions, where each action like solves a specific problem. You adjust the amount of flour. Once you figure that out, you say, all right, like instead of 100 grams, I should have been using 110 grams, so on and so forth. After each change, you make that commit. And then once you're kind of happy with that, then you submit that. What you would do in the Git world is you would push that entire new recipe onto the cloud, onto GitHub. Okay. So yeah, I've kind of alluded to branches, and branches are kind of like, you start off with your original code, your original project, right, your original recipe. And from there, you say, okay, I am gonna develop it further in a specific way. Or there might be a real big problem with like the code, and you're like, I'm gonna debug this code specifically by making this copy of that original repo and, experimenting, tweaking, fixing, figuring out, developing something new on that branch. So any changes that happen now on your branch aren't going to be changing that original main repo. It'll be kind of restricted, constrained to what you're doing. And all of those changes are actually going to be monitored. So in GitHub, so that if you like delete a line, it'll show that it's deleted something. If you added a line, it'll show that it's added something. You added a file or a folder, all of those changes are kind of being tracked. So eventually, once you're finished with your changes in your branch and you give it to a reviewer, they can hypothetically look at every specific change that has been made compared to where you started. Okay. So the master main branch, I don't know whether you should call it a source of truth, but it's kind of like your starting off point. Originally, like the main branch is kind of like empty often, how people work, and then like from there people take on subtasks. So once each subtask is completed, they update the main branch so that it has more and more functionality. It's really important is that independent branches should not contain conflicts. Like Git and GitHub, if a conflict is kind of like two people working on the same part, so you have like two branches now off of the main branch, and like, how are you going to merge that back to the main branch when like these two people have independently changed stuff, right? It doesn't really make sense. So like you have to work on like specific parts separately. And if you don't, then like you will have problems kind of merging it back with your main master branch. A caution is, even if you are working on like separate, and something which has happened with me and collaborators I've worked with, even when you're working like with separate files, like if you have interdependencies between the files, like suppose like one file is referencing like a function in another file, what if like one researcher changes that function that you reference in this other file, and you're still using it without knowledge of that change, and yeah, it might be that it doesn't work anymore.
I guess on that point, how do you mitigate somebody's like
Communication, yeah. If someone is working on like a file or a function or a code snippet which is used elsewhere, they need to notify those people that that's happening, because otherwise like your entire thing can break down.
Maybe this is the wrong point to ask about it, but I had looked into like GitHub Actions, right? And it seems like this almost like an automated checks, right? So then you run it and you make sure, okay, this functionality hasn't changed. Are you going to talk about that at all today, or is that something you've worked with at all?
GitHub Actions, I don't.
No worries.
Okay, yeah.
Just derailing it.
Okay, yeah. As I said, I'm not a big expert. I'm sure there is stuff like that which helps with
Yeah.
it.
No worries.
Okay. What is a feature branch? It's mostly used to distinguish from the main branch, so I'm not going to talk about it that much. But I will use feature branch, but just think of it as a branch. Yeah. What does it mean to push changes? You make changes on your local system. Any of those changes, right, your collaborators, until you push it to remote, will not be privy to. They will not be able to see any of that change made. Once you push it to remote, and your collaborator then downloads in a sense those changes, then they can start working with your changes, or at least see those changes. Okay. Yeah, and the pull command can basically, whenever you call pull, it will look at all the changes that collaborators have pushed and kind of download them onto your system. So long as there are no conflicts. Yeah, because suppose like two collaborators have changed the same file, and then you try to pull those two. Actually, it won't allow you to push as well. So anyway, yeah, technicalities. We're gonna be talking about pull requests and how those work. That's kind of the small tutorial I'm going to be going over. Pull requests is kind of like the nomenclature in the Git world for submitting a peer review off of a change that has been made. And once we're all happy with the updates made, we can integrate our original code base. So in some cases, you are merging a feature branch with the main branch. In other cases, you have like sub-feature branch, like a branch off of a branch. In that case, you can submit a peer review when everyone's happy with those changes. You would merge those changes on that sub-feature branch onto the feature branch. It's like a visualization here. Like you have, right, the master branch. Each one of these dots represents a commit. Someone, starts off with, so someone creates a master here, makes maybe some small changes here. So that would be the first commit. A collaborator takes that version and starts making changes. They're happy with the changes. They ask at this point kind of other collaborators, are you happy with those changes? The collaborators might be like, you have some error here, you need to make some changes. Once everyone's happy, then you can merge those back with the master. Another example would be someone kind of starts off right with the original master code. Hopefully there's no conflicts between this branch and this branch. But they start working, and then you make like a sub-branch off of that branch. That sub-branch is a component of kind of the development work you're doing in feature 2. You merge that back into that feature branch before this eventually gets merged back to the master branch. And this is kind of the overall workflow. You start off with cloning your repo. Clone your repo. So in the start, right, someone starts off a project. You give it to all your collaborators. They all clone that master branch. Then over time, as changes are made, you pull those changes so that you have the most up-to-date version of the code based off of like the work that your collaborators are doing. When you want to do something, you create a feature branch. You do your work, you commit, so make these incremental changes. When you're kind of happy with your changes, you push those changes. That doesn't mean that it changes the master code. It just means that your changes are now visible to others in remote on github.com, right? Where you can download it. Then you want to eventually have those changes reflected in the master code. So you want to do a review, make sure everyone is happy with those changes, create a pull request. Everyone kind of argues about or is happy about what you've done. When everyone is happy, you merge those onto today's feature branch or the master branch. Does that make sense? This is really important. I think this is kind of the crux of the process. So.
So
Yep.
maybe it would be useful to, I can imagine how this works with industry, like here. Could you maybe talk about in your experience when you work on projects, or maybe like in academia when you have some research idea, you have many collaborators, and how do you go actually about dividing up these subparts, determining the branches, etc.?
Really good question. Someone usually is really close to the data. So, right, maybe the master really starts off only with a reference. As I said, you don't want the data to exist in GitHub, but you know, it might exist in the cloud, or it might exist locally in each of the collaborators' hard drive. So it's like, this is the survey data we're using, or this is, you know, whatever sort of data we are going to be using. Maybe, you know, originally you have a README or a explanatory document which kind of explains the purpose of the project, what you're trying to accomplish, what the hypothesis is. So that kind of exists as like your first starting point. From there, like, you recognize that someone has to clean the data. Maybe there's some, you know, feature engineering involved. Feature engineering is not the feature here. Feature engineering is like you want to create these explanatory variables or something. Or, yeah, it could be any sort of data manipulation, data cleaning. So like one person kind of goes down that path and starts, you know, cleaning and improving the data. Maybe another, while this happens, right, you don't want the rest of the team not to be doing anything. Maybe you have like this starting data set, which is not perfect, but can allow for some level of analysis. So that would be, all right, someone start, you know, analysis, run a regression, try to figure out which regression, type of regression you want to run, or what sort of empirical analysis you want to do. That would be like another branch. Maybe someone is in charge of like descriptive statistics. So that would be like maybe this branch over here. So they're describing what the data looks like. For the most part, these tasks are independent of each other. So, yep.
So, I've been meaning to ask you
Yes.
this question for a while. I don't know if this is a stupid question. So, suppose I'm working with training in the data part, right?
Mhm.
So, and somebody else is working in scripted statistics or something like that. And when I go through the, you know, like the work that they have done, that they have done and posted, so can I make changes in the directory that other people are working on that? Because, you know, like, we might be getting to something that needs to be changed over there else, you know, like.
Yes, you might run into conflicts, yeah.
How do we sort that out then?
So,
Or the
yeah.
person who is working on a particular branch should
Yeah.
themselves, you know, like correct those things.
Yeah.
That's also, how does that work?
yeah.
I mean, that seems like what he's doing with feature 2 going off to feature 3, right? Like, so if your descriptive statistic is feature 3 and the regression is feature 2, then you'd say like, all right, well, feature 2, you did one step, I'm gonna branch off of your thing based off the most recent thing that you
That's right,
pushed.
yeah.
And so you don't just like pull from ether, you ask the person who owns that to say, hey, could you push a copy to some part of the repository that I can then later pull from, and then I'm gonna integrate my changes.
Yeah, there's no hard and fast way of you might, as long as there's communication.
I haven't used this. so I'm just
That's a very good question, and that's, this is no magic bullet, and that's really important to know. Like, the type of problem you've described can only be resolved with non-Git related communication. You know, I am making like maybe a descriptive statistic based off of the original data. If you are cleaning the data and maybe change a variable name, well, then like I need to be made aware of that so that I can, you know, go off of that. So, yeah, good question. Main commands you usually use are git status. You can really get away with like 90% of what you need to do with Git status tells you what changes have you made since you like pulled the repository. Git add, as I mentioned, it's about like staging with changes. I usually use this in the capacity of git add all, because if you're making frequent commits, you kind of want to add all those changes that you're making, but you still have to use it. And then the most important, git push and git pull. Okay. So yeah, there are like 1, 2, 3, 4, 5 steps. I'll quickly go over these and then I'll try to do a demonstration. Fingers crossed everything works out. So you clone, step 1, you clone repository or pull changes. You create your feature branch. I barely use git checkout, but I'll show you why I usually just like switch between one branch and the other using RStudio's interface. I'll show you what that means. So you start developing work, commit, push, as we've talked about. See all what's changed. As I mentioned, use git status, stage changes, git add. I often use git add all, as long as you're making frequent commits. That's kind of the way you go about it. Then you say, okay, based off of what's being added here, commit those changes. Add some message like about what those changes are. That's what this M means. If you did just git commit, that would work as well, but kind of just want some documentation with each commit about what's been changed. You can push those committed changes to remote. So every time you commit, it doesn't mean that your collaborators will have access to those changes. So after maybe like you've developed whatever it is you're working on, satisfied with the progress you've made, you want other people to see it now, then you would get pushed.
So just a question on.
Yep.
So you commit, and it's on your feature branch and everything.
Yep.
Say you want to go back. Say
Yeah.
you want to start reverting. What is your typical best practice for? Oh, I didn't mean to commit there. I actually want to go back a couple steps, restructure.
Yeah, there's some, as I said, these are not the only commands. I usually just, know what I've made mistakes on and go back. But there is a command where it's like, so you can go like git log.
Mm-hmm.
And once you do git log, you'll see all of those commits that you've made in the past. So you'll have like messages associated there. And there's another command which will then say, all right, git use. It's not use, it's something. Take me back to that commit, and then you can start working from there.
Thank you.
My two tricks are then checking out the old version of your branch. So instead of committing if you've committed those branches but you haven't pushed them yet, you could just be like, oh, well, why don't I just check out the version that I was using at the start of the day, make a different commit with a different name and a different message, and then just forget about pushing that original and then just push the new one.
Yeah.
The second thing is that there's a command called rebase, which gets crunchy. And it's basically you have to go through the log files and find out what branches come from where and it's real crunchy and involved, but it is possible.
I've had some really bad experiences with rebase. That's why I was asking.
Yeah, I don't use rebase. But, you don't have to start at the start of your branch. You can start at one of the commits you've made, which is why it's useful to commit often. All right, so once you're satisfied with the changes you've made, you want someone else to look at it, you submit a pull request, you assign a reviewer. The person you want to examine and provide feedback for your work.
Is there a way to assign reviewers in GitHub?
Yes.
Will you be going over that?
Yes.
Okay, great. So you don't have to like use human words. I can just be like, @Tom review.
Yeah. Yeah.
That's pretty cool. Okay.
What do you mean human words?
So I don't have to text Tom and say, hey, can you review my code?
No. Yeah. You'll add him. You'll submit the pull request. You'll get like emails saying, see what I've done is correct or not. Yep. Yeah, so this was step 4. So this is from the perspective of, right, someone who is submitting a pull request. So we're kind of stepping out from that, which is why this one is not numbered. For the reviewer of the pull request, that person, right, gets that ping in his email saying Ryan wants you to review his code. You have 3 options. It's interesting, it's called a pull request, but to initiate it, actually, you have to push your code and then go to GitHub and request the pull request. So the reviewer, interestingly, technically doesn't have to pull that new change at all. They can just go on github.com and say, your code is wrong, change it so-and-so, and once you make those changes, I'll be happy, and then you can merge those changes onto the master branch. That's one method to go about it. You don't even have to download those changes onto your local system. Most likely you're going to want to pull that feature branch that your collaborator has developed, test it out locally, see if everything works. If something kind of doesn't work, you can go to github.com and say so and such thing doesn't work, fix it, or add so and so analysis because your analysis is trash. Use a better methodology in your econometric analysis, whatever it is, right? You could throw anything in there in the comments you're making for as a reviewer. The third option is often when it's not so much about a review, or it is about a review, but it's also about that other person kind of developing that work further and taking it kind of to the next level. Or they're really big problems with the code and you need to kind of redo it. In that case, you would pull that feature branch, just like you did in number 2. But now you want to make changes. You want to personally correct for those. So what you would do, you would generally actually not work in that feature branch. You would create a sub-branch of your own off of that, create changes in there or develop the work further in there. And then once that is done, you would submit your own pull request to merge your changes back onto that feature branch. You'd likely ask for the review from that person who originally created that feature branch. And then when everyone is happy, then you can, once you do that first merge onto the feature branch, then you do another merge onto the main branch. Does that make sense, how that works? Okay. Yeah, and as I said in the last step, this is back for the person submitting the pull request. We would merge the feature branch back to master. Okay, so we have 15 minutes. I wanted to show you kind of how that works. how some of these topics work in R and in GitHub. Apologies if this doesn't go smoothly, but let's see. So here I am in RStudio. I have a project opened up. The project is just, for the purpose of this tutorial. I call it test repo. I am right now, as you see here, in the master. For those online right here, it says I am in the master version of this repo. Okay. It basically has nothing in there. It's kind of like a blank slate that we're starting off with. Okay. I'm not going to go over, because of time, how to connect your local project with GitHub. Lots of good online resources, like how to get a project started, which has that connectivity between our RStudio and GitHub. Like that takes some time. Please, if you haven't done this before, please go over that with kind of the links I've provided. Okay, so let's go to GitHub, see what that looks like. Okay, so my user profile is OEXX616. That's the person who created this repo. And that's my UMN ID. I have a UMN account on GitHub. And yeah, so this is also on GitHub. It's the master as well. Okay. Again, it's the same. It just has, it has basically nothing. Test.r doesn't have anything. It's the same thing as what you see here. Some of these things are data and get ignore. Some of these things, yeah, don't show up there. I told it not to show up. We don't need to have everything over here on GitHub. So, we have a collaborator here, and the collaborator is the other me. It's Meta Haseeb. That's my local Gmail account. I created 2 GitHub accounts. So I've specified a collaborator. You have to do this. The collaborator, now has permissions to change your code or create a branch off of this code, download, originally pull the code onto their local system. Okay, 10 minutes.
Need a little bit of time. It's fine.
Yeah.
We'll get it all in the recording.
Okay. But didn't you say there's a class after this?
Some people might need to leave, but they can always watch the recording later.
Okay. Oh, I see. Here, I'm going to the class.
Yeah, we'll work on it.
Okay. Yeah. I don't think I see the slides. Yeah. So, so the collaborator here is kind of tasked quite trivially with developing a feature branch which has certain functions in it that hypothetically you'd want to use in the rest of your project. Okay, so what other Haseeb does, we see that in this branch, it's called HLE functions. This is a separate branch from the master. This person has worked on certain code, and they've created very basic functions here, and in their own branch. Okay, what that would look like in RStudio would be, you essentially, if I was the other Haseeb Ali, they would create a branch, say H Ali dash branch, and I want to kind of be descriptive here on what this branch does. It generates certain functions, and so yeah, I clicked on this branch icon right there to do that, and it's gonna clone the master repo and create this other branch from where I can start working. I'm gonna actually cancel this because that's how you go about creating those branches. I've obviously already done that. Okay. Okay. So yeah, that person developed this additions to the original master main repo, and now right, I worked on all this code, or this other person worked on all this code, and now wants to ask the original person, Ali XX616. I'm sorry for the two Haseebs here, but it was, I kind of needed two accounts so that I could explain how the back and forth works. So yeah, they were satisfied. What you would do is you would, as I mentioned in those slides, you would say git status in the terminal. Notice that I'm not in the console, I'm in the terminal. And you would say git status. The git status here has, right now it has no changes, but if you were working, so let me actually show you just like a quick example. If I were to add this to here, and maybe here I wanted to do some data analysis, okay? And here I had, obviously all of my data analysis, just like a single thing here. If I were to go to terminal and say, hey, what's the status right now? It would say, I've compared your code to what you had originally, and what I see is that there is this change within code for data analysis. That's different than what you were to start off with. Okay. Okay, right? So then after that, I would say, okay, I want to add that. I want to stage that. I would write git add all. You could specify, maybe you have changes in code, changes in data, in another folder, so on and so forth. In this case, I just have one. I just say all. Whoops, yep. 2 dashes. Okay, and then you would go git commit. You would write a message. The message here is data analysis, right? That's what the file that I added data analysis.r file. Okay, so now it's committed that. It's still local, only I can see those changes that I've made. The final step, if I want to put it on, would be git push. Okay. And then it would push my changes. Again, I'm not going to do this, but once you do that, it's going to push it onto the remote, and your collaborator will be able to view that. Okay. Okay. So now you have notice that, yeah, this person who had made those original changes created a pull request. As I said, a pull request is like a request for a review. So in this case, Haseeb Ali is requesting Ali XX 616 for a review. This person said, I added functions with some custom generated functions that we can use in our project. Do these make sense? Review by end of day, you'd have something like that. Okay, and at that point, you can add your review. You can say something like, this is all wrong, right? You mixed up equations for area and circumference, which, as you note here, is what happened. I purposely, made some errors in the code. And so then I would say, fix these before I approve. I can approve. Okay? And you would submit that review. That person would make changes, and then once those changes have been made, they fix the equations for circumference and area, you would, the reviewer would pull again. Those changes would be reflected, they'd be happy and say, yep, I'm gonna approve because you fixed those mistakes. Yeah, you could comment or request changes. I'm not sure exactly what the difference is between comment and request changes. Seems maybe in this case you would want to do request changes. Okay, and then eventually you would approve. Okay, so what else? Git pull. Yeah, as I mentioned, right, you could go in your local RStudio, you would want to I don't know why this is not working.
I think if you press Q, usually it will quit the terminal. But I don't know, you might need to start a new instance of R.
Yeah. I'll just talk about it then. Yeah, you could, because it's already done, basically you would pull, you would say, oh, okay, like these things work well, or they don't work well. And the third option, as I mentioned, would be to create a new branch off of this branch. And in your new branch, you would be like, okay, like I'm gonna fix those changes myself. And what is going on? Yeah, to fix those changes myself, submit those, and then the person who made the original feature branch can incorporate that into their work. So yeah, that's kind of all I had. I might maybe at some point carefully give a tutorial on how to do all this, because right now we don't have enough time to do it. But if people want me to do that, I can definitely be more careful in setting all this up and sharing that. Yeah, that's it. Yep.
Thank you. I've started at the behest of my co-authors to use GitHub.
Okay,
I've used it for my own, but but now also collaboration, but I hadn't really figured out the
Okay.
pull.
Glad I could talk
I
about
was pushing,
that.
but I wasn't really pulling to merge main branches and so on.
Okay.
One thing that we do though that I found really interesting and kind of also goes back to Ryan's question about like how to communicate. We use the issue
Okay. That's
tab
right. Yeah.
in order
Yeah.
to not talk about issues,
Yeah.
but kind of as a meeting notes, things
Yeah.
we want to explore, you know, can we make a table about this, and then,
Yep.
so that works really well to use that on
Okay.
GitHub.
Yep. Yeah, I've come across it in my job. We don't use it too much, but definitely, it's just we're communicating all the time on Teams, so usually for the most part, like we know what the issues are, but it's definitely another place which you should probably use because it's more self-contained than like the communications you're doing elsewhere about the issues.
Yeah, for example,
Yeah.
can we do a mechanism analysis?
Yeah.
Can we open a new
Yeah,
issue
exactly.
saying mechanism
Yep,
analysis
exactly.
and kind of write
Exactly.
everything that we do in terms
Yeah.
of mechanism, which if
Yeah.
we do that in chat and Teams, then
Yeah,
it's
exactly,
somehow
exactly.
lost in
Exactly.
all the other
Exactly,
things we
exactly.
discussed.
So that's the point. That's exactly the point of why it's important to have that self-contained within the issues. Bad habits don't die easily, but yeah, definitely.
Well, thanks, Haseeb.
Yeah, yeah. Thank you. Stop sharing.